Welcome to the third session of Module 2. This course will enable students to understand various sources of IoT and M2M communication protocols, describe cloud computing and design principles of IoT, become aware of MQTT clients, MQTT server and its programming, understand the architecture and design principles of WSNs, enrich the knowledge about MAC and the routing protocols in WSNs. So these are course objectives. At the end of the course, students will be able to describe the OSI model for the IoT or M2M systems, understand the architecture and design principles for IoT, learn the programming for IoT applications, identify the communication protocols which best suits the WSNs. In this session, we are going to discuss about RPL and 6LoWPAN. RPL, IP version 6 routing protocol for low power lossy networks, that is LLN. So this LLN is a constrained modes network, and here we can achieve low data transfer rate and low packet delivery rate in comparison to IP network, and the links are unstable because of disconnections. RPL non-storing mode, the data flow directs downward in an RPL instance. The flow that will happen from a root at transport layer and it will reach the child node. And at physical layer, the data that will reach from child node to leaf node. In upward situation, while the data is flowing from a leaf or child node to other child node and then to the root in an RPL instance. We can see here the 4 ranks: rank 0, rank 1, rank 2 and rank 3. So the data is moving from D212 to C21 and to the B02 and to the A0. So this is RPL network nodes at 4 ranks and RPL data flow instances for upwards and downward flows in the reverse direction for the downward. RPL data flow feature DODAG, that is destination oriented directed acrylic graph. That is the data flow model, and here we have no share modes, that is disjoint. So in ADFG, where only one set of inputs generate only one set of outputs for the given input set. All inputs are instantaneously available in ADFG. There is no delay in between various inputs. It will happen at each stage. Directed acrylic graph, a data flow model, that is between the nodes. Destination orientation means either upwards directed for the transport layer or downward directed or for the device layer end nodes in a tree-like structure. Acrylic graph means one end input and another end is output. Features of RPL: a routing protocol for the LLNs. RPL message exchanges using the algorithm trickle algorithm, standard RFC 6206. These are the control messages we are going to use: DAO, DIO, IO. advertisement for advertisement, for information objects. Transfer of data at an RPL instance. So data that will be transferred from point to point, that is from one device nodes to one receiver. Or we can transfer the data from one device to many devices, that is point to multi-point. Or the data can be transferred from many devices to one receiver, that is multi-point to point. Now coming to 6LoWPAN, IP version 6 over low power wireless personal area networks. The features are IETF recommended methods for reassembly of fragmentations, and IP version 6 and UDP or ICMP headers compression, and it have the capability of neighbor discovery, and it also supports mesh routing. Data stack uses 6LoWPAN protocol at adaptation layer. Adaptation layer data stack transmits to IP version 6 internet layer. Devices network, nodes having low speed and low power. Example for this is WPAN, that is wireless personal area network. So this is the standard IEEE 802.15.4 standard. So we are using IP version 6. We have headers, security and application data that will be put in a frame. Total device node frame size is 127 bytes. IP version 6 header is 40 bytes and UDP header is 8 bytes. So in this figure A, this is for physical or data link layer. Network devices, we have several devices that are connected. Tens of bits of device application data, maximum 32 bytes app data at single data transfer we can achieve. So this is the standard device node frame, that is 127 bytes. We have the IP version 6 header, we have the UDP header, and the device for that security and for that MAC header, and we have application data. So here the fragmentation that's happening, that is the larger data that will be divided into smaller, and the reassembly joining the divided data into original frame or format. And IP version 6 link layer MTU 1280 bytes for and from network and transport layer. So this represents the adaptation layer in 6LoWPAN protocol. Adaptation layer 6LoWPAN protocol 127 bytes fragmented frames, reassembly into IP version 6 maximum 1280 bytes or fragmentation of IP version 6 MTU 1280 bytes into 127 bytes frame for transfer to device. 1280 bytes into 127 bytes frames, that is fragmentation, and the reverse, that is reassembly. IP version 6 over standard network nodes, a device node having the MAC, that is media access control, that consisting of 25 bytes. For the security purpose, we are going to use the AES 128, that will have 21 bytes. The remaining is the application data. IP version 6 MTU at data link layer, 1280 bytes fragments into frame of 127 bytes, each for single transfer to a device node. Okay, so this is called as fragmentation, dividing 1280 byte fragments into 127 bytes, and each for single transfer to a device node. maximum transmission unit, that is MTU, link layer, that is for 1280 bytes. Link layer frame fragmentation needed in order to communicate frame of 127 bytes over IEEE 802.15.4 modes or devices. Frame of MTU 1280 bytes for transmission to network layer. Fragments from frames from the device of 127 bytes each reassemble into IP version 6 frame. So this is the reference I have used from the textbook Internet of Things Architecture and Design Principles, written by Raj Kamal and published by McGraw-Hill Education. I have obtained the content from the textbook, and that is the end of third session of module 2. Thank you.